Hey guys, it's Vince. Today in this video, we are finalizing the SMCU testing for my client. And this system was built and I've went through the entire build process on my channel. And now, of course, we're at the stage where we're going to test the motors. And I do this on all my systems prior to my clients getting them. So Joanna's going to come in here and you can see I've already got Mach 3 open. I'm going to show you my motor tuning settings for testing. Again, this is for your x-axis. You can see steps per is set at 2000. Velocity, I actually set at 2000. Of course, Mach adjusts its own settings. Acceleration is at 35. Step pulse is at 4. And if I scroll through here from X, Y, Z, and A axis, all settings are the same. Okay? 2000 inches a minute is insanely quick. Okay, most systems will not be able to handle that, not because they simply can't handle it. Steppers do degrade torque the faster they go. They're designed to move weight. They are not designed for acceleration. That being said, if your chassis is not loaded and it's doing a rapid move where it's not actually cutting, you can get some seriously fast rapids, pending, of course, you're holding calibration. And that's on any system. So now what we're going to do is jog. Right now I've got x-axis configured. We'll jog. You can see how insanely quick this is. Go the other way. She is cooking. Bring it back to 0. You'll notice you hear the coils fire, and then when the coils have come to the 0 position on the DRO, the motor is silent. And that's due to the SMCU silent mode. So again, coils are still charged. They're just in a much quieter standby pattern until, once again, we go to jog. So now what I'm going to do is I'm going to show you how to power down the system and do it in a sequence that I use for testing to move this motor to the next drive. So first, we close out of Mach. In session, we're going to power down the system. Now, once the system is powered down, you're free to disconnect the motor from one drive and move it right to the next. And I recommend if you're testing your system, that's exactly the process you should follow. You should never be working on a system that's hot, meaning it's powered. You always unplug and you always be outside of your motion control software. That's best practice. Now we go in reverse. We turn on the system. We come over and turn and go into Mach 3. You'll notice Mach 3 screen where it's telling me that the UC400 is selected. In my case, yes, it is. Of course, the IP address has already been configured for the UC400, and that's why we're able to control the system. I'm going to click OK. Motor coil fires. You hear it go silent. We reset the E-stop, and now we are plugged into our Y-axis. Same process. Go the other way. Let's go to 0. Done. Same process. Now we go in reverse. Kill Mach. Killer system. Come over. Unplug. And just plug in. Now we're going to our Z-axis. And we reverse once again. Sequence, power system on. Come into Mach 3. Once again, UC400 selected, yes. And now we're good. Now, you can go into config under your system hotkeys, and you can select how you would like the button configuration to be to control your Z-axis, your Y-axis, and different other features dealing with Mach 3. You'll notice that on my keyboard, I've already selected these two bottom keys with the left arrow, or I should say the left pointer and the right pointer. This is totally up to you. It's arbitrary. And then I'm going to click OK. I'm just letting you know what I've done. And now we can start the jogging cycle. Good. Off. Cooking. Let's go back to 0. Done. Okay, one more test. But before we go, let's check our e-stop because I did not check that onto my inputs. This switch is set up for normally closed. I'm going to depress it, and Joanna, you might as well come over here and you can show them the reset when I hit the physical switch so you get everything in shot. Here we go. You can notice we've triggered it on our Mach 3 screen. So now I'm going to reset the physical switch, and I will come over here and reset it in Mach 3, and we're back up. We know our switch now is configured and working correctly. One thing I want to point out to my guys out there who consistently ask me about remote table-mounted e-stops. You really don't need a table-mounted e-stop if you want something centrally located to trigger an e-stop condition. Let me explain why. If I come over here, when I have access to my mouse, in my case, it's wireless. Yours may be, it may not, it's irrelevant. What matters is when I go to trigger an e-stop, I can either trigger it by actually pressing the e-stop switch physically on the controller, or I can trigger it just by hitting reset in Mach 3. Most of you have access to your PC somewhere where your robot is, much more usually accessible than where the controller may be mounted. So therefore, my suggestion is, before investing in a table-mounted anything, use the resources you have, learn to understand the system you have, and once again, you can trigger an e-stop just as easily by clicking on the icon on the screen that says reset rather than you hitting the physical switch. So now that we've done that, we'll do the same process. Kill Mach, kill power, and we are now moving our motor once again. Right over. And we're coming right in. Now we're going to our A axis. This will be the final test. Once again, in reverse system. Mach 3. Letting us know once again we've got UC400. Click. And I get a lot of guys that go, well, you do a lot of redundant testing, and I do, because that redundancy is how you learn. You don't learn doing something once. I get guys that message me all the time, oh, I've watched your video to a T, but I can't do what you've shown in the video. If you can't do what someone is showing in any video, and they've done the video for you step by step, you're missing something. I want you to think about what I just said. There is no way you would see the video done, and it's done correctly to get the effect that I've generated or anyone else has generated on screen unless you typically are missing something. I cannot tell you enough. Watch the videos again. Once again, A-axis is plugged in. Everything is set. I've already configured 9 and 0 to be my A-axis. Here we go. 2000. Switch over. And it just keeps going. And I actually was incorrect. I configured 8 and 9, not 9 and 0. But you see what we got, and we're going to go to 0. And that's it, guys. I mean, this system now is fully tested. We know that everything works. The client knows that everything works. Once again, all of the dip switches are preset for these motors. Everything there is done the correct way. And if you guys are testing your own systems, whenever you're doing troubleshooting, once again, process is everything. If you're not doing this every day, and I am, literally every day, then I highly recommend, until you're comfortable working on your own equipment, you should have a legal pad. If you honestly have never learned this type of hardware, it's going to take time. It's not something you're going to pick up by watching some guy on a YouTube video run a 2-minute cut. That's not usually how it happens. It happens with hands-on experience. But when I say hands-on, you have to know how to implement self-learning like an autodidact. If you're not familiar with that is, that's someone that teaches themselves something. What you want to do is go through and document everything, every step you do, to the point of being disgusted with it. That's how you learn. And once you've documented it on top of watching the video in correlation, you will find that you get ahead, and not only get ahead, but mistakes become basically the rarest thing you'll see. Why is that? Because you developed that process. And that's where guys, once again, usually overshoot the runway, so to speak. They say that they've learned something, or we're living in a society now where everything is a 10-second video. And unfortunately, you are not going to learn this in 10 seconds. And if you do learn it in 10 seconds, you need to contact me because I'll hire you. It's not happening. This is fact. This takes time, and anyone who looks at a system of this caliber knows that something like this takes time. It takes time to make things look less complex than they are. And that's something that, again, comes with experience, and you guys will gain experience the more you practice. Whether you're building systems, whether you're doing machining, that's where it all comes from. That hands-on effect of saying, okay, this end mill is not near as sharp as it was. How do I know that? Well, my corners aren't coming out as nice. Things aren't looking good. Then I'll have guys that'll go through and get scientific. Well, I've noticed I've run 15, 20 hours on this end mill, and I know that I can't push past that time frame, or I'm constantly having problems at this feed rate. That's where they become scientific, and that's where they make the most money. So again, I hope that this video has been helpful. I hope you guys have learned a lot. I hope you've now enjoyed seeing what an integrated drive system can do. Many of you have already seen the G540 system, but again, we've had some issues with G540s being able to handle larger motors, larger platforms. That's the beauty of this system. You've got all features integrated into one, and on top of that, now we can support up to 9 amp motors. So there's literally nothing as far as robotics for production use that you really can't power with this. It's really that powerful. So again, one other point I want to make, just stay there a second, is that there's still a lot of debate about stepper motors. I hear it all the time. This is an enclosure that's made on my MakerBot method 3D printer. This 3D printer goes in excess of over $5,000. Okay? It uses stepper motors, guys. This is 0.1 millimeter layers. I'll say it again. It's 0.1 millimeter layers using nylon carbon. The dimensions are exact. The finish is exact. That's just glue from the build plate. And I don't have one. I've got two. So now we have consistency. I want you to think about 0.1 millimeter layer height. And I want you to think about what you're machining. And I want you to think about how many guys have 3D printers that are calibrated, once again, to this kind of accuracy using stepper motors. If accuracy with steppers isn't what I claim it to be, or isn't what you're seeing online with so many 3D printers, then why would we have so many robots that use them? Printers use them. Cutters use them. Think about what I'm saying. Medical equipment use them. The reason we see and hear so much BS about servos being used for typically civilian-based systems is the fact that they are trying to sell you on the fact that they're using what they claim is the latest technology. The bottom line is then, if that's the case, all 3D printers should basically be thrown out because they're using older technology. But why are we able to produce this? Now, not everybody can produce this, but does that mean that because I can produce this and you can't, that it's the stepper motor fault? No. It means that I've taken the time to learn the equipment I've purchased. That's the difference. That's the difference between a guy buying this system and making $40,000 a month. Why? Because he understands what he purchased. And that's the truth. You can give the people the same tools. It does not mean that they're going to get the same effect. And it's a fact. If you become scientific in what you're doing, you'll get to the point where you can look and you can see exactly what I'm saying. The MakerBot method is considered by most in the 3D printer market who've done any research to be one of the worst 3D printers. I picked mine up for $1,000, and those are the parts I produce. I didn't listen to what people said. I listened to what I had and what I wanted to spend. So me showing you this is proving to you, don't believe bullshit. Believe real. Try it for yourself, then call me full of shit. But if I'm right, and your friends are using 3D printers that use stepper motors, and all these other people are showing you robots, laser cutters that are using stepper motors, obviously something is amiss. I mean, if servos are so great, basically all other robots would be obsolete. It doesn't work that way. So again, I hope that I've made my point. One other clear point, I will actually show you the method printing to show what's possible, how it produces this. And I know that's kind of elementary in the sense that many of you have seen 3D printers print. But what I find interesting is when guys message me and say, I can't get my method to print. How do you get your method to print? It doesn't print like that. It jams. It does this. It does that. Are you checking the temperatures? Are you checking the build plate? I can go on and on. I don't know what you're doing because you're not me. You don't have my experience. And that's why you can't produce this. And that's fact. So before looking at spending on the latest and greatest hardware, because the next guy on YouTube said that's the latest and greatest, think about your budget. Think about what the truth is that I just said. 3D printers would all be extinct if they had to all convert over to servo motors. Doesn't happen. It's because the people learn the hardware, not the other way around. The hardware doesn't make the person. So again, I hope that this video has been helpful. Thank you guys all for your support. Have a great weekend.